Okay, so we're going to look at creating quadratic equations, and specifically in this case from a word problem we have here. So it says you're a person on a bridge, okay, and we'll try to build a diagram, something like this. The arch of the bridge is 92 meters tall, so we're going to assume that's at its highest peak. If it's an arch, it probably does something like this, and we're going to assume at its highest peak it's 92 meters tall. And it's 140 meters from the left pole to the right pole, so I guess across here. That's how wide it is. Okay. Build an equation to represent this. Okay, now there's technically like an infinite number of equations we can build. So what we're going to do is we're going to work around parts of the coordinate plane that we're really used to using. So that'll be our y, and this will be our x-axis. And we're going to draw a rough sketch of this. So we'll label these things for us. This will be our y, and this will be our x. And they said at its peak, it was 92 meters tall. Because it's an arch or a parabola shape, they're symmetrical. So what we're going to go on the assumption here is that we're going to say the highest point is actually on the y-axis. Okay, so we'll say this here is at the value of 92. Okay, in other words, this coordinate is 0 and 92. And if it's the highest peak of a parabola, do you know what that's usually called? The highest or lowest peak of a parabola?
The vertex?
Yeah, the vertex. So that means this is the vertex. Okay, so the vertex of the parabola is at this coordinate. And we're going to assume the x-axis is kind of like the ground, where the bridge is connecting to the earth. So we'll say this is the left pole, right? So this is our left pole, and this is our right pole. Okay, they should be symmetrical. I don't know if I've actually built them symmetrical. And we should get, oh, I can't look at those things. Can I? Here we go. Oh, no, I don't know how to do it. Oh, never mind. I'll just drop my hand. It does something like that, though that's not drawn very well. Here's the idea of our arch. We do know that the distance from pole to pole is how far?
140 meters.
Great. Which means, how far is it from the vertex? How far to the right is it, and how far to the left?
70?
Yeah, exactly. Because it's symmetrical, that means this coordinate here will be at 70, so the x value is 70, and the y value, well, it's the ground, is 0. And this one here is negative 70 and 0. Okay, so we have three really major coordinates. These are considered x-intercepts, actually. So these are the x-intercepts, and this is the vertex. I can build an equation using two different forms. Okay, so let's actually go into that. Because I have so much information, let's do it in black here. I have so much information. I'm going to build one equation using vertex form and one of them using factored form. And maybe we will do some wonderful converting to show how they're the same in the end. So, if you remember vertex form, vertex is written as y is equal to a x minus h plus squared plus k. Is that familiar?
No.
How about y is equal to a x minus r x minus s?
Yeah.
That's familiar?
Yeah.
Okay. Vertex is something you're going to get to then. So in this case, what we'll look at is factored form, and we'll start with factored form, and then I'll talk about vertex form so you have an idea and show you that it's just another form of the equation. So the r and the s are our x-intercepts. Okay, that's this coordinate here and this coordinate here. So the r is one of them and the s is one of them. So we're going to plug those 70 and negative 70 into this equation. So we get y is equal to, a is still unknown, and I'm going to put it in red because a is actually what we're going to solve for in a little bit. X subtract 70, and I wish those buttons were working. X subtract negative 70. Negative 70. Okay. I want you to kind of get an idea of here. And that's technically subtract positive 70. So we get y is equal to a. This ends up being x minus 70. And remember, that's where I plugged in the positive value. And where I plug in the negative value ends up being plus 70. Okay. So we've got some good pieces of information. We still need an a value. Okay. And we can solve that because right now there are technically three unknowns. Okay. A y, an a, and an x. Well, there's two x's, but they represent the same thing. X and y are always in our graph. The a is really important to us. So we need another coordinate, which we have, 0 and 92. This represents an x value, and this represents a y value. So we can plug those in. Okay, so y was 92. Well, I guess I'll do those in red. Okay, so y is 92 is equal to, a is what we're trying to solve for, and x is 0 at that point. So 0 minus 70 and 0 plus 70. Okay, and I'm just going to highlight A because A's, oh, that's not a good highlighting color. Here you go. A is what we're looking for. Okay, so now what we do is isolate for A. So let's solve those brackets. 92 is equal to A times negative 70 times positive 70. That's going to give us 92 is equal to A negative 49,000. Or 4,900, sorry. Yeah, 4,900. Yeah, okay. To isolate for A, we need to divide by that value. Okay, so A is equal to 92 divided by negative 4,900. I could get a decimal value here. Let's actually go about doing that quickly. 92 divide bracket negative 4,900. And I get a really ugly decimal. I'm just going to leave it as a fraction. It doesn't matter. If you feel more comfortable with fractions or decimals, do whichever you like. But I now can build an equation. Okay, my equation can read y equals, I'm sure I can at least reduce this fraction. Maybe we'll do that. 92 divided by 2 will give us 41. 41 over, if I divide that by 2, I get 2, 4, 5, 0. Maybe I can reduce that more, okay? So here's our A value, x minus 70, x plus 70, okay? And that's the equation. And I can use that to find any point along this arch here, okay? So we've now done it in factor form. I'm going to quickly show you vertex form, and I won't convert after because this is already kind of long. But I want to show you vertex form because that would have been a really easy way to do this also, okay? Because we have a lot of info. So let's jump back down. Because I have the vertex, okay, there's two letters in vertex form. One is an H, and H represents the x value, and there's a K. I actually did these in the wrong color, so I usually do it this way, so I'm going to do it that way. That's the H, and the K represents the y value, okay? So if you notice, I have a K, and I have an H, so I'm going to plug those values in. Y equals A is the unknown, X. Now, our H represents our X, so we plug 0 in for H. So minus 0 doesn't really do much for us. Square. And our K value is 92. It's our Y value, so plus 92. Okay? Well, the last thing I need to solve for, go away, thank you, is our A value. The exact same thing. We have our information. I got to find my A value. I already know my, I need to know another X and Y coordinate, and I can use either X intercept. Okay, so maybe I'll use the negative 70 and 0 in this case. Okay, so a Y is 0 and X is negative 70. So Y is 0, so we replace Y with 0. Let's use black. Is equal to A. X is negative 70, so we're going to say negative 70 minus 0 squared plus 92. Okay, and what I did there, I didn't highlight it very well. So I replaced 0, the Y, and negative 70 with that coordinate. So I use that coordinate for the X and Y. Does that make sense?
Yeah.
Yeah. Okay. And now we simply isolate for A. So 0 equals A negative 70 squared plus 92. I'm going to do two steps here. I'll bring 92 to the other side, so it becomes negative 92 equals A. And negative 70 times negative 70 is positive 4,900. Remember we multiplied 70 and 70? To isolate for A, I got to divide. I get negative 92 over 4,900. You remember that being the same A value?
Yeah.
Same A value, but in vertex form, I'll reduce it. So we reduce it there. We get Y equals negative 41 over 2, 4, 5. But in vertex form, the next part's a little different. So we have x minus 0 squared plus 92. Both represent identical equations, just in different forms. In this form, we can see the vertex very easily. In this form, we can see our x-intercepts very easily. And that's the major difference between the two.